Yes, we can.
Slides here. Okay, cool. Brilliant. All right, awesome. So I was invited here by Ethan to give you guys a fun talk on some cool things on binaries and household devices. There's, of course, been a slight title change from what was sold to you, but I swear it's not a bait and switch. You're still going to get generally the same stuff. If you're interested in any of the slides, I'm going to have this link here on the bottom left. It's going to be there again at the end of the slides, and I can post it in the Zoom chat if you guys want, but you can access them there. So I think without further ado, let's get into it. And I'll first introduce myself so you get an idea of like, what is this all about? Who's this bro yapping at you? And hopefully it's something interesting. So I'm Zion Leonahe Boski. I'm a PhD student at Arizona State University. I'm in my last year. I do a lot of research on hacking techniques, reverse engineering, different hacking tech like tools you use when you're doing the automation of the process. Um, so I do a lot of this kind of research. I also own my own company, so I do some of the consulting that is in that space of doing research. In addition to this kind of like academic background I also have a background in competitive hacking, and not like competitive hacking where you're programming stuff, but competitive hacking where you're legitimately finding security vulnerabilities and things. I've done this in competitions called CTFs, and these CTFs have largely allowed me to kind of travel all over the globe. I've gone to places like Poland, I've gone to Vietnam, I've gone to Abu Dhabi. I've been kind of all over the world seeing what it's like to go against the top hackers. And what I think is the most important, learning what makes a top hacker a top hacker. So I got to compete against a lot of these guys. And, I think that makes for a pretty cool perspective. Now, aside from that, I've gotten to take some of that and I've gotten a little fame on this competition. This picture here is a picture of me in a TV show called um, The Campus Tour or something. This was an Amazon Prime show where I got to, of course, play a hacker as I am a hacker. So there's that. I've gotten to travel doing talks on these topics like, what does it take to make automated hacking techniques, whether it be in artificial intelligence or just general stuff. And most recently, I've been in teams where we run about $2 million from the government for a AI cyber reasoning system that hacks and patches things on the fly. So generally, I have a lot of kind of experience in this area of what does it take to do research, but what does it take to be a hacker and to find cool things? Now, you might be asking, why am I, right? Like there's the who am I, but then there's also the why am I, right? Why am I here today to talk to you guys? And I hope to kind of get like two objectives out of talking to you. The first one is to inspire you to hack binaries specifically, right? These are like things you'll encounter in your everyday life, and to play CTFs to get better at being able to do these actual things. The second one is to empower you with more resources to start hacking. So I hope after I entice you with what is this cool realm of hacking, I know many of you have already started. You're in the gray hats, so you're doing phenomenally already. But I want to empower you guys to be able to do even more. Hopefully, that means like finding 0 days in the future or things like that. So let's take a step back into what is the world as we know it right now. Everything on this planet, whether you're driving a car, you're messaging your friend, you're visiting a website, is run by software now. Software rules much of the world that is running around us. You can imagine why we see so much news about hackers and how they're such a big threat to society. And that's because in reality, they actually are. There is so much of your daily life that depends on software working correctly and software working safely. And I'm sure many of you have already realized that in doing your different challenges, right? Like this is something that's very important. What's interesting is that how you actually interact with software is different than you might think, right? When you go onto GitHub, you can read the source code of different open source projects. Chromium, the backbone of Google Chrome, is actually one of those projects. You can read the source code. But when you're executing the source code, you're actually using a binary. A binary is a compiled version of source, right? So here's GCC, a normal compiler you might use. You put in your big source code, and what comes out is this big shareable unit that you can execute on a CPU. And this is what you use in your everyday life. When you go and double click on the Chrome icon, it executes a binary. It doesn't execute source code like in a debugger. It's actually running a binary that has lost much of the information of the source. this is, really kind of a big deal here. This, I want to emphasize it, right? When you're running code on your computer modernly, there is no source code. The source code did make the binary, but companies aren't going to give you that binary. When you open Google Chrome, you don't have the source on your computer. When you run Microsoft Word, you don't have the source to like what is Microsoft Word. Even Windows, right? All of your Windows machine, your kernel, the devices you run, these are all completely just binaries. How do you really know what's going on, right? These are how all of the world is running. And you actually run into them every day, right? Like I said, Google Chrome already, Microsoft Word, many different operating systems are fully closed sourced. You only ever get the binary. And then even your favorite games, maybe you like Counter-Strike 2, something you see daily. I hope you don't see it daily, crazy game. But if you do, right, this too is a binary. To reason about it, to edit it is actually quite difficult. And this is where hackers live, right? This is the hardest part of actually interfacing with these programs is like, how do I understand it? Binaries also, aside from what you guys get to run into in your everyday life, binaries are also some of the most critical pieces of software. I want to emphasize that not all programs compile down to binaries, right? You might go and visit a website, and I'm sure you guys are already familiar with JavaScript and HTML. These are not compiled languages. These are just languages that are either rendering your site or making things look cool, but they are not compiled. Compiled programs, on the other hand, can be found in some of the craziest places, like cars, autonomous cars, any of the cars you might get in. I'm here in Phoenix right now. We have a service called Waymo. It just drives you anywhere, right? That is running on a binary. Pacemakers, like legitimate pacemakers you can find that get installed in people from Queens Hospital, right? Like they actually have binaries running on it. There's Bluetooth on them. These can be hacked, these can be destroyed, but they're binaries, so they're hard to understand. You have drones, right? Like all of the warfare you see in Ukraine, these are largely binaries. Hacking them is also difficult. And then routers or common home devices, like anything that runs in your smart home, including the critical device that lets you connect to the internet. These are all only binaries. And for you to understand what they do is quite difficult. So why is it difficult, right? I'm saying all this stuff that these binaries live on your computer, they live on your devices, they live all over the place, and that they're hard to understand. But why are they hard to understand? Well, it's because when you go and you look at a binary, it doesn't look like this. It doesn't look like nice, pretty source code. It often looks like this. It's a graph. Usually it's just actual legitimate ones and zeros, but modern techniques can turn it into a graph and you can view it as a graph. This is called disassembly, but this is still like terrible to look at. Like Zion, where is my normal source code? Where is the thing I'm familiar with? Because this definitely ain't it. This is some ugly, crazy thing. So we created some modern tools for hacking. One such thing is called a decompiler. Maybe some of you have used the decompiler before. If you have, like hit me with that reaction if you have. If you've used the decompiler like Ghidra. Right, but these tools also don't give us something completely comprehensible. On the right-hand side is something that Ghidra might output, and this does not look like source code in any form, right? It's disgusting. It's huge. There's dozens of crazy if statements. Like this is worse than a freshman undergrad would write in their 101 class. Like this is insane. It doesn't even look like a human wrote it, but it also doesn't even look like an AI wrote it. It just looks terrible. And this is what decompilers output. So to reason about this kind of stuff is quite hard, right? Like there's very few people in the world who can reason about it correctly, find bugs, and exploit them. And that's kind of where society has left us, the hackers, right? Like there's the good hackers, there's the bad hackers, whatever, what have you, right? Like hackers are the ones who convert these binaries and actually understand them, right? You like toil around in the craziness that most people can't quite comprehend. And you figure out where are the problems and where are the bugs. And when we find the bug that no other person has ever discovered, we call these 0 days. I want to make a big point about how different a 0 day is from just like a 1 day. A 1 day is a bug many people know about. It's like not updating your driver, right? And it says, oh no, right, this is a version that has been exploited before. 0 days, on the other hand, are bugs that work on the latest version. No one has found them yet except for you, These are 0 days. And hackers are the main way by which we produce 0 days. These 0 days can be purchased for up to millions of dollars. They're sold by nation states. They are discovered by governments. They're paid for by Google, right? There is a lot of crazy stuff you can do in 0 days. And these 0 days are like what hackers are for. This is what we are for, is reasoning about these binaries because no one else can. So what's the big hype here? I'm hyping you guys up about 0 days and how they're very cool and very impactful. Well, let's take a look at just one example 0 day. This is less of a 0 day. It's more of a bug, but we won't cross lines here. The CrowdStrike bug of 2024. Maybe you heard of this. Maybe you were traveling when it happened. Here's a picture from an airport when this went down, the CrowdStrike 2024 bug. It's a very, very simple bug. It is just a overread, like when you index on the seventh index, but your array was only 6 long. This single tiny bug, which was found only in the binary on PCs across the world, in airports and airplanes, this bug cost around $5.4 billion for just one bug. That's how much it costs society. This is actually still being updated because they're not quite sure how much money people lost during this period. So 0 days can be quite expensive. This wasn't even a weaponized one. This was just an accident. There can also be some really dangerous 0 days, like a Tesla 0 day. This is a Tesla 0 day in 2025. This is a 0 day that allows you to control a car from its power port. So basically, you like walk up to the Tesla, you open the power port area where you would normally charge it, you plug in the power charger, and from there, you essentially have full shell access to the rest of the car through some very cheeky exploits. This allows you to, now next time the person starts up the car, you could just take autonomous control, smash them into a wall, right? Like these are the things you can do when you know how to reason about binaries. You have this power over the world that, not many people realize is even possible. This single bug was worth $50,000. I have a colleague of mine who got a similar bug in the Linux kernel, and it was worth around $200,000. So these are, expensive things that can be sold for high amounts of money. So I've talked a bit about 0 days and binaries. Before I move on, I want to see if anybody has any questions about this kind of introductory information. Like, what is a binary? What is this stuff? Any questions so far? I'll give it a second. I think we're good. Cool. So what I want to move into now is how you can use this knowledge of binaries and how the world works under the hood to find real 0 days. I want to talk about a 0 day instance of something I found. Me and my colleagues found in different household devices that you might find interesting, and how you can kind of reproduce the same concept. That this isn't so difficult, that even with just a little bit of security training and work and trying discovery and CTFs, you too can be a 0 day hunter. Well, let's talk about routers. Routers, a target I had talked about earlier. What exactly is a router, right? A router is something you'll find in pretty much every household. Everyone who is connected right now to Zoom and hearing me speak is hearing it through a router. All of the packets that make up this Zoom call go through a router first, and they make it to you, and you send back a request saying, "Hey, I received all the information. Please send me more." And that's what a router does. It's this middle thing, right? So to dig in a little deeper of what exactly a router is, right? A router is something that helps you connect to the internet, and it turns many devices into a single point of internet access. So specifically, right, you've seen this before if you've ever run ifconfig or some kind of IP stuff inside of your terminal. This is usually the first kind of hacker thing you'll do when you start looking at terminals. You'll see that you have a private IP. It's probably something like 192.168.1.2. This is a private or a local IP. Now, this IP address isn't your real IP address, which I'm sure you're aware of. You have a public IP address, and the public IP address is actually the IP address of your router. The router talks to everybody else, and then it sanctions out information to all the private IP addresses. So you want to talk to Google, right? You're going onto your laptop, you connect to your router, and you want to go to google.com. So you send that request to the router first. The router gets google.com, and then the router sends it to Google. So Google then sends back the HTML, which will render this Google site. It goes through the router first, and then it goes to your laptop. Why I bring this up is because you can see that routers are kind of your middleman to all of the internet. There's, of course, more steps between Google and the router. There's like ISPs, and there's people that control more of the internet. But generally speaking, your router and the router of people across the globe, routers are how you actually talk to everything. So you can see that they might be a kind of critical piece of the software chain. And as you already know, these are also run by binaries. So how do you, well, first let's talk about some router brands, which I'm pretty sure most of you have one of these. Netgear, Linksys, Asus, TP-Link. All of these routers are generally the same. All of them under the hood are running Linux. And this Linux operating system is controlling what packets make it to you and what packets don't. Uh, I'm just going to guess here and say most of the people probably connected right now to this call are on Netgear routers. Um, Netgear routers are usually pretty cheap, like you buy it off of Amazon. You might have an Asus one too. Linksys is on the more expensive side, but I'll bet it's somewhere between Netgear and Asus for most people here. If you don't know, don't worry. Very soon you'll be seeing a picture of a Netgear router. So let's talk about how you actually like where is the binary? I'm telling you, binaries exist, and there's all this stuff about binaries, binary. How do you actually get a binary if you have a router? Like, I come up to you, I say, Zion, or I say, hey, hacker from Gray Hats, here's this router, please hack it. Get the binary, find some bugs. Well, to get the binary, you really have two options. Your first option is to jack into the physical device and grab it off the system. This is a little bit more complicated and it's really variant based on the type of router and the type of layout of the actual hardware. The second option, which is extremely common for everybody here, will be yoinking it right off their website. I'm sure you guys are already aware when you update your router, when you go into the router settings, like usually you log in as admin and you say, okay, I'd like to update the firmware. You go to update the firmware and it downloads the firmware from the internet. That also means that that firmware must be publicly accessible to everybody. Like everyone has to be able to download that firmware because you're unauthenticated. So that means you can actually get the firmware that's likely in your house right now. Like if you go to netgear.com, you search up the firmware, you can download it. I'm sure many of you have seen like what firmware is before, but you don't really know like what exactly is firmware. So we'll get into that. Right. After you have the firmware, firmware isn't exactly a binary. It's a packed set of binaries and file systems. So you want to use a unpacker on it. The most common way to figure out where binaries are on these types of systems is a command called binwalk. Most of you can install it right now on a Linux machine. It's also on Mac OS, so it's actually quite easy to get your hands on it. It's not an illegal tool or anything. It is quite a normal tool we use for security analysis every day. This will unpack the binary, the firmware, and it will get you a bunch of binaries, not just one. So you take these binaries and you say, okay, I'm a hacker. I'm looking to get some bugs. And you pop it into Ghidra. Ghidra is a decompiler you can use. It's an open source one made by the National Security Agency. Hopefully, some of you have had a try with it before. But you take this binary, you put it in a decompiler, and then you look for bugs. Ideally, you find a bug, whatever the hell a bug is. You find this bug, and then you use the bug to exploit the actual router. So just like how you would normally request to go to google.com, you can then send a bug instead, and the bug will somehow do some crazy stuff on the inside and give you access to the router. And now you own the router, right? You own it. This router is yours. You might have been able to exploit it remotely. Like I'm all the way here in Arizona, and we're going to talk about exploiting your routers in Hawaii, right? So like there's a total way to do this. And once you take control of the router, you can do a bunch of things. You could pivot to new devices. Often on your own local network, there's actually going to be kind of more unupdated devices. Like if you have a curtain rod opener or if you have a smart stove, which is a real thing, many of these will be exploitable on the LAN side, on your router side. You could intercept packets. You could, snoop on people, see what websites they're going to. And you can even troll unknowing victims, right? You can just shut off the router. You can just meme them. You can do ridiculous stuff by having control of this actual router. So here's a picture of a real router that I think some of you have. I'm just going to guess and say some of you actually have this router. Possible. We'll see. And now I'm going to actually show you a real demo of exploiting this real router with a real zero day that we discovered. This zero day has been patched in the latest version of your router. So ideally, if you updated it in the last 2 years, because we found it 2 years ago, hopefully it's fixed. If it's not, you're in trouble. And I'll show you what it all means. So let's get out of here and let's go to the terminal. Can everybody see this terminal?
Yes.
Confirm. Awesome. Thank you. So I have this terminal here, and I want to just briefly do the steps I just said that you could do yourself, right? So I downloaded the firmware from Netgear. Here it is. It's this .image, whatever the hell .image is, and I can actually do a binwalk-e on it. Oh, that's not the way to spell binwalk. I could do binwalk on it, and it does a bunch of stuff. It uncompresses some things. And now it uncompressed this file. All right, let's unzip this. What is here? Here we go. We unzip it again because apparently it had 2 zips of the image. So this is binwalk again. And now if we go and look at it, it's quite interesting. Here is what it looks like inside the router. Now, I'm going to try and get some interactiveness, but does anyone recognize like what this layout kind of looks like over here? This layout of files. We're looking at files that are existing on this router. And I'll give it a second if anyone has any guesses, or I might just like randomly start picking people. I saw Nathan join, so maybe I'll target Nathan and ask him like what do these files look like? Yeah, pick Nathan. All right, Nathan. Nathan, if you're here, like what do these files look like? Right? We're seeing files that are on a router. It's kind of neat because they look familiar.
So just like the normal Linux file system layout.
Yeah, exactly. It's the normal Linux file system layout. So, like I was saying earlier, these like routers that you're running in your home are running Linux. Like it's actually Linux. We can see real things in the files. Like there's data here, there's licenses. I believe there's like the website that you normally run when you want to connect to it. Like you go to the admin login, you can find HTML files. But most importantly, we go to the bin folder and we find binaries for days. Like we can do, let's clear this. Let's do file of whatever curl is. Curl is a binary. It's an ELF and it's running ARM, right? Or it's not running ARM, it's for the ARM architecture. So this is like a special architecture thing. Now, there's lots of binaries here, and hunting for bugs is quite a complicated process. It's pretty advanced. But let's say for an instant, like you kind of have an idea of what bug you're looking for. One super easy and kind of stupid way to look for bugs is to grep for things you think are vulnerable. A common bug in firmware and in like many things are command injections. And those command injections can be accessed when you do something called system. So like I can grep for system and I can see which binaries have any call to system. There's actually quite a bunch here, but we're going to focus on one that I've already kind of identified earlier, and it's this one, PU HTTP sniff. So let's do that again. Here is a binary called PU HTTP sniff. So this is a binary living on top of the router. And what it actually does is it sniffs, it listens to packets as you guys are on the internet. So this, again, this is on the real router, right? Like it's actually listening to every packet and it records it for some set amount of time. I don't know. To me, when I first found that, it kind of sounds like malware, but it's not, or maybe it is. So we can take a closer look at this actual binary in the way that I said earlier. We can take it, let's just pop it open into Ghidra. Ghidra is the decompiler any of you guys can get. It's completely free. And we can just run it into Ghidra. Give it a second. That is not the Ghidra one I wanted. Let's do the second one. Cool. right? So now we have Ghidra open. It's got some stuff, whatever. It's kind of scary looking. We're going to ignore a lot of the things on the screen, but like if we go to a function over here, we can go and jump to functions. We can actually start seeing C code on this right-hand side, or at least like the resemblance of C code. Now, what we can do is we can actually search for a very specific type of thing. The thing we're looking for is, let's see if I can search. We are looking for system. Here's system. So let's search for system. Yeah, let's search for it. And we can see that it's used in a bunch of places in the binary here. Let's just pick the first one. So we pick the first one and we see some stuff. There's a bunch of code that looks like C code, but this is actually the logic of how our own router works. Like it does things, and we can read that logic and understand what it does now, even though all we have is the binary. On this left-hand side, right, like it looks like this. It's crazy assembly. It's terrible to look at. I'm not looking at that. I barely know ARM assembly, right? But I can look at this decompilation and I can start making decisions about what I think this binary does without going too much into detail of what exactly it does. We can just make some guesses, right? Like here is this string called user agent. Is anyone here familiar with web? Does anybody know what a user agent is? I'll give it a second again. There's no wrong answers here, guys. Anyone can guess. It's okay. I don't want to just target Nathan because he'll probably get it right. So does anybody have an idea of what a user agent is? And you don't need to think about binary, like think about web in the general sense.
Usually like the web browser somebody is using, like a
Yeah,
specific kind.
exactly. Yeah. You got it. So normally when you visit a website, right, it says user agent and then the browser you're using. If you're on Firefox, it says Firefox, and then it usually also says your operating system. And then if you're on like an iPhone, you'll say Safari and some other details about your iPhone. So the user agent is just like what you said. It is the thing, the software system that is accessing this current site, web page, server, whatever the hell it is. We made a protocol on the internet for HTTP where we said anytime you talk to a device or a thing, you need to say who you are, and that's the user agent. So this like code seems to be taking the user agent, whatever it is, and it's putting it into this variable here, this PC var1, right? We don't need to know too much about it, but let's just kind of roll with it. It takes that PC var1 and it puts it into another variable using scanf. And then after it puts it in scanf, it uses it in the command line right here, this command line interface. So it's actually calling like bash with system. It's calling bash edil dash I dash s, which is user agent, and then our actual user agent. Now, the crazy thing about this, like this is sniffing every single packet that goes through our router. It's parsing what is the user agent and it's using it as part of a system command. Now, I'm going to just straight up tell you this is insane bonkers because you should never, ever in your life be using a untrusted command in your bash. Like, I think all of you know that. Like, do not use untrusted commands in bash in your terminal. It will hack you. And this is very much the case. User agent is something we control. We are not forced to actually be truthful about our user agent. When you use Firefox, Firefox is being nice by telling the website it is Firefox. It can actually lie. It could say it's Safari. It can say, hello, I am Zion in the literal user agent. So that means we can also put commands in there. Like we could put bash commands in our user agent. And that's really, really bad because you can do anything that needs if you have the correct user agent. So now I kind of want to expand on that and show you what that really means. So here is, let's go back to our bash here. So we have that binary that we talked about. And I have written a exploit that tries to exploit that thing that we just talked about, that bad command. So here it is. Here's the exploit. It's actually quite simple. And I'll put that more in the center of the screen so everybody can see it. Let's put this back. It's actually quite simple. I'm just doing a series of commands in the middle, but it does a curl. Curl is the way you can interact with the web if you're not using a web browser. It's like a simple request sending software. And -A is how we can set our own user agent. This is like us saying whatever we want about the user agent. Right here, this whole string is what I'm saying is the user agent. I'm saying it's test semicolon LED CLI all S whatever all this stuff is sleep one and then halt dot dash F. Halt dash F is the command to shut down whatever system it is run on. And this is of course the IP address of the router locally, but you can also access it remotely. So let's show what this actually looks like. Like let's get real. I have a actual camera set up here. Can everybody see this camera view?
Yeah, we can see.
Okay, cool. So this is a real camera. Here, this is my hand. Just to show you proof, here's the computer. Here is another computer I have. To do this exploit, I need to be connected to this router. This is a normal router you could buy right now. So on the left-hand side of the router off the screen, I have this computer. This is my wife's computer, hilariously. I need it because if I were to do this on my computer, then I would be shutting off my internet in a second. So what I'm going to show you guys is actually exploiting this router. So here is the video of it. And now in a few seconds, I'm going to hit the enter on this keyboard, which runs the same command that we saw earlier. What you guys should see in a few seconds is that the lights will go off. So I am running it in 3, 2, 1, hit the run button. There we go. So all that's left is the power indicator saying that there is power and it is currently in shutdown mode. All the other lights went off and this is starting to get hot because I own the router. I am on this router now and I can actually control whatever I want. I could send more commands if I want. I can say like, hey, I don't care what this router does. Open up a bash shell and start like playing Rickroll or whatever, right? So I own the router. And that's what we just did here. So like with our simple knowledge of some simple security primitives, like, I won't lie, they're not all exactly straightforward, right? Like just being able to analyze this code in the binary, we're able to have such a powerful primitive. I own this router now. I have the ability to pivot on any machine in the entire world that is running this in their household. Last we checked, there was around 20,000 of these routers running. We saw an even bigger number before, right? So like you can just remote into this household, control the router, and do whatever you want on the router. And this is a real bug that existed, a real 0-day that we found a few years ago, and you guys can find it too if you so desire the skills. All right, so let's get up to the wrap up slides about what that was all about, right? I showed you the bug in general, right? This is the bug for people who are more curious. You can go look at it more. I also have a blog where I wrote about a lot of this. You can go and find it here on the bottom, this link. It shows you some of the crazy stuff we discovered in the chain to be able to exploit this router and really tells you how to go about understanding binaries, these things that rule our world. Just to like tell you what this exploit does, the curl -a is, like I said, the curl command to set your own agent, like you can set your user agent who is talking to the website now, test, and this very smartly placed like quote is to break out of the command. This is to end the quote, so you break out of it. Right here, you can put as many commands as you like. What we did when we actually exploited this in the wild was we uploaded an entire SOCAT server and we just reconnected a bunch of times. And then finally, this last command is the IP address of our router, which is a local IP address. So I want to kind of start finishing up this with telling you guys how you can achieve something similar. I'm not here to sell you anything. I'm genuinely here to hopefully inspire you to start hacking yourself to secure these systems, right? This is a router that could really realistically be running right now in your house. Like you should go check. Actually, if you visit this site, we even have a live running instance of it. Maybe I'll show you it real quick. Like If you go to this blog and then you click on this link here, this destruction link, this link launches. The moment it launches, it tries to run this attack against you, which will just turn off the router. You can, of course, read all the source code yourself. It is a fairly small amount of source. Yeah, a fairly small amount of source code. And it's a very similar thing to what I just showed you, where you set the user agent to do something crazy. All right, let's finish up. Right. So to kind of go into this final thing of how to hack, right? The media would have you believe that hackers look like this. This is a episode from Mr. Robot. It's like crazy sound, and you just automatically know how to hack. And that's just not true, right? Like hacking in reality looks more like this. It's like less appealing is all these nerds gathered around one person with a computer, and you like all scream if they do something good. It's awesome. But like it's not what the media tells it is. And a way that you can get it to be more cool, right? To like hit this coolness factor of doing stuff like epically, you can play in these things called CTFs, capture the flags. I see it as a type of 0-day training. There is you that connects over the internet to challenges they have, and you exploit them to get a flag. Why I think it's so useful is because it has a very familiar setup to normal 0-day hunting. The organizers send you a binary, you hack it, you find a new vulnerability, one that you're not going to read about online, right? Like this is not some rerunning of Metasploit. This is a completely new bug that the organizers wrote for you. So no one has seen it before. And then once you exploit that, you show proof of control, the flag. We did exactly that on the router as well. The proof of control was me shutting it off, shutting the lights off, so you could see that I'm actually exploiting it. If you are interested in this kind of competitions, there is an actual place to look for it. I know the word CTF is used a lot now. People kind of use it incorrectly and for really lame competitions that are not CTFs. There's a difference. So I kind of challenge you to go to this site, ctftime.org, if you're not already familiar with it, and try to learn like, oh, okay, like, hey, there's all these competitions. There's ones going on this weekend. You can play in them. When you click on it to CTF time and you look for upcoming events, just pay attention to this weights. A 0 weight means it's probably a risky CTF that no one can really say is good. Higher the weight, the better. For instance, upcoming on the 17th of October is a hacking competition called HackLoo, which in my opinion is one of the best hacking competitions in the world. So if you guys want, you should try it out. It is a great place to start. CTFs teach us how to do 0-day hunting and how to understand binaries. I also highly recommend playing in a team. CTFs are kind of boring and lame alone. There are teams you can play on. Gray Hats has, of course, its own team. We have our team called Shellfish, and we're always happy to have other people play with us. You should reach out to Ethan and Nathan if you're interested in something like that. But generally, it's really fun to do these competitions with friends. Like getting in a room together, staying there for 48 hours like absolute crackheads is actually quite fun when you solve these challenges and you get that kind of like high of being really good at something technical. You can also use online education. We created this from the Shellfish team. I was just showing you these guys, many of them in this room. We created a platform called Pwn College, which maybe you've already used before, thanks to some of your great officers. Pwn College is this like free online hacking dojo system we created. It sets up all the challenges. It does a bunch of fun stuff for you that you can completely do yourself. There's also belts like orange, yellow, green, and blue belt. You can do it. I had a lot of fun doing it. I had a lot of fun creating the challenges too, once I was more senior. So these are like really fun things to do. I'll also note that some employers will actually take these belts as a form of merit. For instance, the National Security Agency directly recognizes this belt system. They use it internally for some of their trainees. Just 3 weeks ago, we were actually in DC doing a training for the NSA that literally did this content. So if you're interested in hacking binaries, I highly recommend checking out Pwn College because really you can do it too. What I want to finish on here is that although media makes a lot of blips about what hacking is, like what does it mean to be a hacker? What does a real hacker look like? Well, sometimes reality is actually media. It converges on reality. This scene I showed you is actually a very specific scene from Mr. Robot. This is Mr. Robot, season 3, episode 1. He's working on qualifying for DEF CON CTF. It is the World Olympics of Hacking. He's trying to qualify for it. And this scene was actually directly inspired by, so this is their after talk show host, by our team Shellfish and by a real hacking scenario. This was us trying to qualify for DEF CON quals a few years ago. So, right, like reality actually converges on media when reality is badass, right? Like they didn't make up these concepts about hacking and how cool it is and how you can break into systems. They actually took that from reality. Media isn't always a lie. And in this case, right, like it is true. You really can be a hacker and do really badass stuff. And on that note, I am all done with the actual slides and such, and I'm happy to take any questions, any kind of extended questions you guys have, and if you're curious about the general hacking journey or what it takes to do some of this cool stuff. Thank you very much. And I will see if there is any messages. And can I be a hacker but bad at math here? I'm going to stop sharing the screen for a second so I can more directly read these. Let's see. Yeah, can I be a hacker but bad at math? Huh. Yeah, I think you can do it. I think you can be a hacker but be bad at math. Not every hacker I know is good at math. Like one person that worked on me with a like we worked on a 0 day before. He's actually terrible at mathematics, but he's quite good at like breaking things. I think some of the best parts of hackers is mathematics. Like I personally love mathematics, but you don't have to. I think some of the best parts of hackers is that like curiosity to just kind of mess with things. Like if you've ever played a game and you've just like started spamming stuff into walls or something and all of a sudden you glitch through a wall, right? Like this is hacking. Like this is the beginnings. They're just messing with things in creative ways. And eventually it evolves because you start really understanding how the system works. And that understanding allows you to just do ridiculous things. All right, let's see. Are there more free online resources we can use to learn how to hack? There are more free online resources. Yes. There is some stuff like Hack the Box is not bad. Personally, I still recommend Pwned College if you want to do stuff that's binary related and kind of holds your hand through the exploitation process. I think there's some really, really basic stuff there that you can start with, like just Linux. Like you don't have to do binaries at first. You can start with just Linux and how do you use the command line and slowly work your way up with videos and stuff. Hack the Box is pretty cool at times. I like CTFs in general. Those are usually always free. So those are fun hacking resources. I also have some kind of more fringe ones that are more for like figuring out how to hack like challenges. They're called war game sites, such as reversing KR. This is really fun for like reversing Windows binaries. And another one is called Pwnable KR, which is like your first introduction to how to exploit challenges. It doesn't hold your hand as much, but they are for beginners. They're not meant to be like stupid hard. Yeah, so those are still like two that I would recommend, and a CTF maybe called Pico CTF. So Pico CTF is another good one. More questions, guys. Oh, and someone asked a private question about our lab that we have. We do apprenticeships. There should be apprenticeship next year at my lab. Not really doing an ad for it here, but if you're interested, you can search up a lab called SEPCOM, uh, and we do apprenticeships if you're looking to work with hackers who work on this kind of stuff. More questions. Questions about routers. Can you hack my friend's Instagram? Okay, here we go. Here we go. What made you want to start hacking? What made me want to start hacking? Let's see. I wanted to start hacking because I wanted to run video games on my laptop. So I'm actually from Hawaii too. I am from the Big Island, but I went to Kamehameha High School um, up at Kapalama. And at Kamehameha, they gave everybody like a MacBook Air to do work on. And of course, you might download games on it. The first time I ever started hacking was to figure out how to bypass the school filters on what was a runnable, like what was a runnable program, the whitelist and the blacklist of what was runnable. And then hilariously, I would distribute that knowledge to the rest of the class and like spread out how you guys can all start running video games on your laptops. Like, and it wasn't particularly complicated, like really advanced like it is now. Like I wasn't using even Bash. I was just opening application properties, finding the internal program like in iMessage and swapping out with like Minecraft and then running that. So like I think I started just out of need. Like I really wanted to play games. This is my first time owning like a full laptop. And I was like, okay, I gotta play games. After that, I just kind of stayed interested. And when I came here to ASU many years ago, there was a hacking team, much like Gray Hats, that like brought me in and they were like, hey, this is what real hacking looks like. And I was just lost in the sauce after that. It was just too cool. I spent every weekend doing it for about a year and it was just the best time. Is that lab in Arizona? Yeah, CEPCOM is in Arizona. We have apprenticeships here, so yeah. How consistent would we have to be in this? And how consistent were you with hacking when you started? Okay, cool. I kind of answered that just a second ago. When I was a freshman in hacking, like, or freshman in computer science, and like I had never really done hacking before, like on the C level or on the Bash level, I played CTFs for about 1 year straight, every single weekend. I was like hooked on it, even though they were so hard and impossible. Um, and for a whole year, I didn't capture a single flag by myself. It was terribly tragic. And somehow I come back the next year, and on the first CTF, I just got like 8 flags. And when I got those flags, I was hooked. I was like, holy crap, this is awesome. Everything after that in computer science was just trivial because CTFs were so much harder than everything else I had learned in all of my computer science classes at ASU to date. Like, legitimately, nothing was harder. I learned every single thing before my classes in CTFs, like compiler theory, optimizations, general computer theoretics, like all of it I had learned previous to the classes because CTFs. Um, as far as consistency goes, you don't need to be as crazy as that. At the time I did it, there wasn't any education platforms like Pwn College. I think Pwn College makes it a lot easier to be part-time, so to say, part-time in this space. You know, like dedicating something like 20 hours a week would be awesome, but I think like 10 hours a week would really do it for you. You keep doing this, you show interest, you show skill, like you can learn for some of these platforms and you can get a type of certification that could help you in a real job. I think the most important thing for getting an actual job is being good at what you say you are. Like, be good at hacking. Don't get a cert, like, be good at it first and then get certified or whatever the hell you want. And how consistent were you when you started? Yeah, okay, I answered that. Do you know if Pico CTF recognized in the same manner like Pwn College? I think Pico CTF is highly recognized. I think if you want it or like you got highly ranked in it, I think that would make a big deal. That would be really cool. Um, yeah, so I think it matters, like putting Pico CTF by name. This, of course, only matters if you're going to like a bigger security place. Like if you're going to just like a startup, it may not matter because they wouldn't know. But for somewhere like the NSA or the Department of Defense, Raytheon, uh, TP-Link, even I talked about earlier, Trend Micro, Microsoft, Google, these are all places that may recognize that more directly because they have real, like legit, real security people that really know what they're doing. Is CompTIA Security Plus a good certification? I get asked about certifications a lot, and personally, I have very little knowledge and use for certifications. I'd say there are two different worlds you can go into in security. There is the pen testing world, and pen testing relies heavily on having these type of certifications. So I'd say if you're into pen testing and that's what you want to do, you should definitely get one of these certs. There is the other side of the world, which is more about general security design and zero-day hunting. And these have nothing to do with certifications. These are all about raw skill. I'd say what is more important than a certification is being able to show you're skillful and that you actually have some way to do that. Some easy ways to show skills to have a blog about doing challenges. You'll be surprised like how easy it is to hire somebody if they have an interesting blog. Like what is interesting, you go home today, you have some like smart light, like smart LED in your house. Unscrew the LED, put a USB into the side because there's probably a USB, download the binary, get the firmware, and reverse it. And just reverse it. You don't even need to find a bug. Like open it in IDA, open it in Ghidra, write it on your blog. That is quite interesting, and I think could be worth more than a certification. These kind of details that show you are passionate and know about security. So I'd say, yeah, my opinions are mixed on certification. Maybe ask a more pen testing oriented person. For a beginner, oh, it's Ethan. For a beginner learning how to do Pwn Rev for the first time, would you recommend using AI tools like Diala or learning the basics without any assistance? Hmm, that is a very complicated and somewhat advanced question. So Ethan is asking if you should use AI while reversing or hacking for the first time. I would caution you to not. I would say do not do it. I would try your best to refrain from using AI until you're stuck. AI is a great unstucker. It can tell you things, but as far as the learning process goes, it can be more helpful to do it yourself. So I'd say minimize AI use when you're doing these for the first time until you get completely stuck. If you get completely stuck, maybe ask the AI like what it thinks of the situation. AI is quite advanced nowadays. You can really use an LLM to hack real binaries. Um, but if you want to be able to keep doing it into the future, it is valuable to learn it yourself and then utilize AI as you get more knowledgeable. More questions. More questions. Did you guys like the crazy setup, the like camera, this camera I have over here? Nice. Yeah. If I started a hacking blog that I wanted to show employers, would I let that information be public via using my real name or private with an alias? You can do either. I usually have my private alias. My hacking blog is this one, mahalos.re. Um, it's funny saying my hacking name in Hawaii because everybody here actually knows what Mahalo means. We're in the mainland, like nobody knows what the hell I'm talking about. But anyway, having a pseudonym is fine for your blog. It's cool to have it. But like when you put it on your resume, just make sure you connect the dots. Like I am this pseudonym. I put my real name usually somewhere on my blog because it makes it easier for people to like consistently know who I am across platforms. So they like in like personal branding, right? Like having my real name and my pseudonym makes it associated that Mahalo's is Zion Bosky. So kind of up to you. Do you surf? I do surf, yeah. Yeah, I do surf with my dad. My dad, all of my family still lives in Hawaii. My dad is from or not Waianae. He's from he's from Wahiwa, so he goes surfing often in like North Shore, and then usually I'll go surfing with him. Not in North Shore because I'm a noob. I'm not as good as him, but I'll go surfing too. The rest of my family's from the Big Island, so yeah, I'll surf when I come home. Usually like every 6 months or so. What OS would be yeah, a Wahiwa, yeah, driving for 2 hours to get to school. Uh, what OS would be the best for this? Would you personally recommend Mac or Windows? I would recommend neither of those. Do not use Mac, do not use Windows. I'm using Mac because I'm a final year PhD student, so I'm in the middle of like becoming a professor. Maybe next year you'll see me as a professor at University of Hawaii. Hopefully, if I'm there, come take my class. But I wouldn't recommend Mac or Windows. Highly recommend using Linux. Like, please, guys, it's so hard for me to get students to just use Linux. For all of the years up until the last 3 years of my PhD, I was a Linux user. I used it every day as my desktop. Just use Linux. Linux is a great way for you to learn not only how your computer works, because it will crash at some point, but also how to dev in an environment where you control everything. You're going to learn a lot because things are going to keep breaking. But in the age of AI and LLMs, it is so easy to fix things when they break. Just slap it into an LLM. this is not something you need to suffer through. You can just ask an LLM to help you. So like use Linux, at the very least dual boot, right? Like Windows, Linux, you can do both. Try Linux out, Ubuntu basic, just keep it real, right? It's the best way. Nice. Comments about Wahila. It's so far. I might live in Wahila next year, so like I'm also hating it. It's too far. The traffic is nuts. It's crazy. Any other questions? Hope you guys are happy with your general stuff you do at Gray Hats and you cover more of this kind of content. Oh, let's see. So most hackers use LLMs these days. Yeah, yeah, most hackers use LLMs these days. I would lie to you if I said otherwise. Me personally, I use a large language model every single day. I use it for coding really fast. And then I use it for actually like reverse engineering binaries. Like I can use it for it to reverse engineer a whole thing. I don't recommend it because it will be wrong in very subtle ways even now, but it can be an empowering tool to like get past things fast. Like I forget bash commands all the time. I just like search up what I need to do. Like, hey, write me a bash command that iterates over all of these files, checks the first byte, and if it's one, do this, if it's zero, do that, and then it just writes a bash command. So I'd say most hackers are using large language models. It is here and it will continue to be here. Use tools at your disposal, but don't make them a crutch. Oh, I got a nice DM to do another plug. In December, I'm running a capture the flag, which will be very much like I already described. I'm running it in Hawaii at a conference called AXAC. It will be in the worst place on Oahu. It will be in Waikiki, so it will be there. But you guys should be able to join remotely onto the CTF and play. It'll be hosted in Pone College, which is a great place to like generally host a CTF for longevity if you're interested in it. Additionally, if any of you are very advanced, I'm looking for maybe one or two more challenge authors. Anyone who would like to write a CTF challenge, if you know how to. If you don't, just come around for the actual competition when it happens in December. It should be a fun one. Just for people to see, this is an example of what the competition looked like last year, since I also ran it last year. Here is the link. It's called AXAC. So it is a conference that runs in December. Any other questions? And Lily et al., please cut me off if we are going overtime. I don't know the actual end time, so I can like just keep yapping. I don't know.
No, yeah. So 5:30 is usually our cutoff. I think we'll
Okay,
be
cool.
putting up. Thank you so much for the presentation. That was super sick. If
Yeah.
anyone has any other questions, I think I saw Zion join the Discord.
Yeah, I'm in the
Yes.
Discord as Mahalos. And I just
Yes.
message in general. This is Zion. Feel free to message me, DM me, put anything there. I'm happy to respond.
Yeah, so just either DM Zion or ask one of the officers and we can always forward your questions along.